In this last video with working with logarithms, we are going to do a few things where we're approximating using calculators or Desmos or something like that. So in the previous examples, we were giving you problems where you could find exact values, and we're kind of switching up to the approximate values. So in example 8, we are supposed to use the graph of 3 to the x to approximate the log base 3 of 60. So it's a little bit weird because they haven't given us the graph of the logarithm, they've given us the graph of 3 to the x. So the thing that we need to recognize about this is I want to rewrite this in logarithmic form. So I am going to say it is the log base 3 of y equals x. We have to remember the translation that whatever the base of the exponential is becomes the base or the subscript of the logarithm. Whatever the exponent is on the exponential becomes the answer, and then whatever the answer was on the original one becomes the input on the inside. So there are all of our translations, and I'm going to go ahead and erase that because it's a little distracting. So what we want to approximate is log base 3 of 60. So if we look at this, log base 3 of 60, if we say that that equals an x, then that's equivalent to saying 3 to the what equals 60. What we're wanting to try to do is find out when is the output of the exponential function equal to 60. So right here is when the output equals 60, and we are trying to solve for the input. And it looks like, just kind of guessing, that it's approximately 3.75. Now I'm going to show you in Desmos two ways that we could solve this. So the first way that we could solve is we could just solve graphically. We could put y equals 3 to the x in here, and we could put y equals 60. And we can't see, so we'll just zoom out. I'm pinching on the y-axis, and then I'll click for the intersection, 3.727. The other way that we could do this is we could actually just put the expression into our calculator. So we could say log base 3 of 60. And what I want you to notice is that the y-coordinate of the intersection point, the x-coordinate of the intersection point, 3.727, is the same as what Desmos evaluates log base 3 of 60 to be, 3.72, and then this would round to 7. So the next problems ask us to solve and to round each equation to the nearest 10,000th. So this says log of 5x plus 3 equals 2. Well, what we need to do is recognize that a regular logarithm means log with a base of 10. So this says 10 squared equals 5x plus 3, or 100 equals 5x plus 3. This one won't really require much in the way of approximation. Subtract 3, we get 97, and then divide by 5, so 97 fifths equals x. And if we wanted to get a decimal approximation, we would just grab our calculator and do 97 over 5. And we get 19.4. So x equals 19.4. And since it specifically said to the nearest 10,000, we are going to go ahead and go out to the 10,000ths place. So this is hundredths, thousandths. Oh, nope, that's not it. Sorry. We need to go out further. So this is tenths, hundredths, thousandths, 10,000ths place. Okay, our next example, remember that is an L, so if it helps you write it as a cursive L, ln, which really means a logarithm with a base of e. So log base e of 2x subtract 4 equals 3. That's the same thing as saying e cubed equals 2x subtract 4. Then I'm going to add 4 to both sides and divide by 2. Now on your calculator, you would find the E button, which is right here, and you would start with parentheses. So you'd have parentheses, and then you would do e to the third plus 4, and then divided by 2. Probably an easier way to do this is in Desmos. We're going to do the same thing. I am going to put parentheses. I'm going to go to the ABC. I'm going to go E, back to this, e to the fourth, arrow out. Oh, actually it was e cubed. So e cubed plus 4, and then divided by 2. So it's about 12.0428. And if you wanted to check this answer, all you would do is you would take this answer and put it back in the X right here. And in order to get a natural logarithm, the button is right here. So you do natural log 2 times 12.0428, subtract 4, and the answer that you get in your calculator is 3.000003. There's some rounding there because we did some rounding here. Okay, and the last one is not in logarithm form, it is in exponential form. So what we're going to do on this is we're going to go ahead and translate from exponential form instead to logarithm form. So it is going to be a log base 10 of 3 equals t plus 1. So remember, the base of the exponential becomes the base, the answer on the other side becomes the input, and the exponent on the exponential is what goes to the other side. And if I just checked again, I would do 10 to the t plus 1 equals 3. Now there's no way for me to know this answer without my calculator or some sort of graphing software. So this, you're going to get an approximation in your calculator. But before we do that, we need to go ahead and fully isolate the t, and we do that by subtracting 1. So my final answer would be t equals log of 3 subtract 1. Now the reason I was able to just say log with no base is, remember, if it is a base of 10, that is what's called the common logarithm, and you can just kind of cross that off. If it's a base of e, like on the previous example, that is a natural logarithm. So I'm just going to enter this into my calculator. And on a TI-83 or an 84, the log button is just right here. So you're just going to enter log, exactly like this is entered, log 3, close the parentheses, and then subtract 1. And the answer I get is approximately negative 0.5229. And to check, we would just put that back into the original equation. And the answer I get in my calculator is 2.9998, which does round to 3, so it checks. So we're going to put our answer in a solution set with it rounded. So if you want, you can say approximately equals, and we should also do that on this previous example here. So just as a reminder, when we are solving logarithms, anything involving logarithms, you just need to remember this translation. If I have b to the y equals x, that is equivalent to a log base b of x equals y. So we're looking at the base of the exponential is the base of the logarithm. The exponent of the exponential is the answer. That should be a y there. And then the answer to the exponential is the input of the logarithm. And I do want to encourage you, especially in this week and all of the further weeks when we're working with logarithms, please reach out for help. Your teachers, that's what we're here for. We have online office hours, we have email, you have ways of contacting us. Also use those walkthrough tutorials in Pearson. Use the Help Me Solve This when it's available. So there are lots of resources out there, and I know that it is difficult to learn something like this without having access to your teachers. So reach out and use the resources and the ways of accessing us that we have set out for you. And I hope that you have a great week. Let us know what you're up to. Make sure you do all your check-ins, do everything on Moodle, and signing off for now.